Alright guys, this video is going to be about enthalpy of a reaction, and we're going to find this by using the enthalpies of formation. Alright, so enthalpy of a reaction, and you just have to think of delta H, which is enthalpy, is the same as heat, okay? There's a little more to it, but for the most part you can think of it as heat. And so the last thing we did with heat was Q. It's the same thing. Alright, so, alright, delta H of a reaction can be found using the delta H sub F, and that's the enthalpies of formation. Okay, so like with the last video, if you don't have this in your notes yet, you might want to pause it between sentences so you can get it all written down. Alright, so the enthalpy of formation is the amount of heat produced or absorbed when 1 mole of a substance is produced from its naturally occurring elements. Okay, so can SO2 be produced from naturally occurring elements? Yes, it can. And the reaction would be sulfur plus O2 makes sulfur dioxide. And on your worksheet, you should have this table right here. Okay, if we look on that, it says that the delta H of formation for SO2 right here is negative 296.1 kilojoules per mole. All right, and I just want to remind you that in this explanation, it says when 1 mole of the substance is produced. So this makes 1 mole of SO2 from its naturally occurring elements, and the delta H of formation is negative 296.1 kilojoules per mole. Okay. So what about, bring this down here. What about SO3? Well, that can also be made from sulfur and oxygen. The only difference is, since we can only make 1 mole of this, when we balance this reaction, we can't change this to 2. So we would use 3/2, and that's where those fractions comes in balancing equations. So 3/2 of an oxygen gives us 3 oxygen atoms. I'm not going to have you guys do that, but I do want you to realize what would be naturally occurring and what wouldn't be. Okay? All right, and so the delta HF of this one is going to be negative 395.2. So if this reaction happens exactly like it's written, where 1 sulfur reacts with 3/2 of an oxygen to give us 1 SO3, this much heat would be produced. So it would be an exothermic process. All right. So now let's think about this one. Move this, whoops. Back down here. Oh. What is going on? Okay, so what about oxygen? Oxygen cannot be made from naturally occurring elements because it is a naturally occurring element. So its delta H of formation is equal to 0. All right? That's why on this, you're not going to see anything like zinc by itself, or H2 because that's the way it naturally occurs. Sodium, magnesium, all those things naturally occur that way. Fluorine. All right, so they're not going to be on here, and all of the delta H of formations for all of these would be equal to 0. Okay, so now if we want to know how to find the delta H of a reaction, right, that's the purpose of this video, I'm going to move this out of the way and move all this stuff up. The equation that we would use is the delta H. Oh, my pen is not connecting. For reaction is equal to okay, so what this basically says is it says the sum of, that's what this symbol means, the sum of delta H of F, the delta H of formation of the products, so we add up together all the delta H of formation for the products, multiplied by their coefficients, how many moles they have, minus the sum of all the delta H formations of the reactants times their coefficients. So if we look at this reaction, we could find the delta H of the reaction for this one by using those values that we found earlier up here. Okay, we're not going to get into why or how that works. Oops. We're just going to do this. So it's products minus reactants, right? Because it's delta. And delta means final minus initial with a chemical reaction. The final is the product, and the initial is the reactant. So it's products minus reactants. Okay. So SO3 we found to be negative 395.2. That's kilojoules per mole. And then SO2 we found to be negative 296.1. kilojoules per mole. And then oxygen is 0, right? Because it can't be formed from its naturally occurring elements. So it's going to be negative 395.2 times 2, because this is per mole, and we've got 2 moles in this reaction forming. That's what this N stands for. It's moles. So it's going to be 2 times negative 395.2, because it's products minus reactants. So there's our products, and then the sum of the reactants is going to be 2 times 296.1 negative plus 0. And so if we put that into the calculator, we get negative 198.2 kilojoules, because the moles canceled out. All right, so let's try one more, or 2 more maybe. All right, so the reaction is going to be that. And if I look at my information here, What is going on? Okay. It says that NH4Cl is negative 315.4. NH3 is negative 46.2. And HCl is negative 92.3. So I'm going to take my products and add them together and subtract from the reactants. Now, in this particular reaction, all of these are 1. So we don't have to really multiply it by the coefficients because we've only got 1 mole of each. So I'm going to get negative 315.4 minus products minus reactants minus 46.2 plus negative 92.3. All right, so if I put that into my calculator, I get negative 176.9 kilojoules. Okay, so I'm going to try one more. And the reaction that I want to do is one of the ones off of your worksheet, if I can find it in this big, huge mess that I have here. Okay. So first I'm going to find all my delta H's of formation. So water, and this one, water is liquid. So I need to make sure I use the liquid water right here and not the gas water. So you need to really pay attention to that, especially for water. It's real easy to get those mixed up. So it's negative 285.8. Carbon dioxide is negative 393.5 right here. Oxygen is 0, and CH4 is negative 74.8. So I'm going to take the sum of the products times their coefficients. So it's going to be 2 times negative 285.8, because of the 2 right here, plus 1 times negative 393.5, because there's only 1. Sorry, minus 0 for oxygen. And you can write 2 times 0 if you want. Plus 1 times negative 74.8. So I'm going to put that all in my calculator. And really the best way to do this for you guys is to, whoa, it's not my pen, is to find this, and then subtract the 2. All right, so for this first one I get negative 965.1. And then for this one I'll have negative 74.8. And I need to subtract those 2 from each other. And I get negative 890.4 0.3. All right, that's it, guys. Good luck.